I'm Tanya. I'm an OpenSciEd teacher and facilitator, and today we're going to dig into Lesson 5 of the McKenna unit. This 2-day lesson is an investigation lesson, and we're going to take some time to dig into some tips and tricks later on about how to make sure this investigation goes smoothly for you and your students. But before we jump into the investigation and what your kiddos will be doing, let's take a minute and remember how we got here. In Lesson 4, we figured out that food gets absorbed into the body in a healthy digestive system, but McKenna's waste still has some food molecules left over. We also learned that fiber never gets digested, and this is because it's a really, really large molecule. This left us wondering, what is actually happening to those larger molecules in the digestive system so they're actually able to get absorbed into our body? So let's take a little closer look at this lesson. This is an investigation lesson that takes 2 days. There's about 60 minutes of materials preparation in advance, and do be aware that some of this preparation requires you to set up some materials the day before and set overnight. This is a hands-on investigation for your students, but no devices are required. And there are 2 videos that can be used to help during this. So this lesson is 2 days, and it can be broken down into 3 major sense-making chunks for students. The first major sense-making chunk happens on day 1. Here the students navigate into the lesson by remembering what they had figured out about how there were no food molecules remaining in a healthy person's waste, and how we decided we wanted to look more closely at the start of the digestive system, being the mouth. Students then slowly eat a cracker and notice that if they chew it slow enough, it starts to taste a little sweet, kind of like sugar. If you're not allowed to have your kiddos eat food in the classroom, that's perfectly fine, because one of those 2 videos is a supplemental video that's student-facing for this particular reason. What we now figure out is our first key moment, and this is where, at this point, your students will probably be saying they think the cracker is being broken down. This leads us then to revisit our learning from prior units, specifically the bath bombs unit, where we learned about chemical reactions. We then review graphs and notice that while some complex carbohydrates are decreasing, we see glucose increasing. This is kind of puzzling and gets us thinking, how can we have more of something that wasn't there to begin with? This leads us to our second major sense-making chunk, where we move to a reading which outlines what happens when we chew our food and it mixes with our saliva. Here we gain the words enzyme and specifically the word amylase. This brings us to noticing your students may have said in prior lessons, which is that starch looks like a bunch of glucose molecules all put together. We're now thinking that maybe the big molecule is being broken into smaller molecules, and this leads us to wanting to test this idea. We think maybe we could use some of the enzymes to try to digest food outside of the body. We could then use this to see a before and an after digestion to see if there's changes in these molecules. This brings us to our final sense-making chunk. Here students complete an investigation using amylase and food to figure out that chemical reactions happen when starches interact with the stuff in our saliva. We know this because we didn't have a positive Benedict's test for glucose in the samples without the amylase, but we did have a positive Benedict's test for the glucose in the samples with the amylase. This means the atoms in the complex carbohydrates became the atoms in the glucose through a chemical reaction. So over the course of these 2 days, your students have now figured out that while complex carbohydrates decrease in the mouth, the number of glucose molecules are increasing. This is because of a chemical reaction between the starch and amylase, making the large starch molecules break down into glucose. Let's dig in a little bit more on these key moments. In part 3 on day 1, our first key moment is when we revisit our learning in the 7.1 bath bombs unit on chemical reactions. Here it's helpful to have your students refer back to when they learned about what a chemical reaction is and how this is different from a physical change of a substance and what is considered evidence for chemical reactions. If you've not done the 7.1 unit, you may need to slow down a little bit at this point and dig into it a little bit deeper with your students so they can understand these concepts before moving forward. The big idea you want your students to get here is that one way we could figure out if the changes that are happening in the mouth are a chemical reaction or not is by figuring out if we're making new stuff from old stuff, or if we're just crunching it up into smaller pieces instead. This leads us directly to looking at some data. The next key moment is in part 4. The data is comparing the food molecules that occur in the graham cracker itself and then the food molecules that are present in the mouth after chewing. This is a key moment where students realize that there are actually more glucose molecules in the mouth than there was in the original graham cracker. What's also interesting is they notice that the complex carbohydrates are decreasing by the same amount that the glucose is increasing. As always, go slow with this data and take time to clarify the legend so that your students know exactly what's happening. But by this point, they've seen data that looks like this several times, so they can probably just tune into it pretty quickly. Now, the next key moment is in part 5, and we're wondering what's in our mouth that's making one type of food molecule increase. We decide we need to learn more about spit, which we eventually start to call saliva. Your students will learn from this reading that there's an enzyme called amylase in saliva that mixes with food. During this, the enzyme starts to break down the food. This leads them to want to see if chemical reactions are actually happening in the mouth. Now, during part 9, the building understandings discussion, this is the final key moment where your students take the time to process the data that they've collected from their investigation and make sense of what they've figured out. Your students will now know that a chemical reaction happens when starches interact with enzymes in our saliva. Their evidence for this is that we didn't have that positive Benedict's test for sugar in the samples without amylase, but we did have a positive Benedict's test for glucose in the samples with the amylase. Those original samples had no glucose in it to begin with. The students now know that the amylase is what is needed for the chemical reaction to start in the mouth and turn the starch into glucose. So where do we go from here? How are we going to actually navigate to the next lesson? We know the large molecules can't get absorbed, but they seem to still be decreasing and aren't found in waste. At this point, your students are wondering if the large molecules are getting absorbed someplace else in the digestive system, like the large intestine. They may also start to wonder if these large molecules are breaking down by chemical reactions. It's important not to confirm whether it's a chemical reaction at this point, because this will be something they figure out in future lessons. Now let's take a minute and dig into those tips and tricks and the materials management for this lesson. First, just like last time, make sure to test the food samples that you've allowed to sit overnight. The rice, the crackers, and the taco shells should only have complex carbohydrates in them, no glucose. So make sure to check the food labels in advance to make sure there's no sugars in them. But I found in the past, sometimes there's a small amount of glucose present in the morning, so I would just not use that particular food sample if it's giving a positive test for the Benedict solution before the students even try their investigation. Next, make sure to keep the amylase cold if you're not using it for a large period of time. The directions on how to prepare the amylase is in the teacher's guide. Also make sure that the amylase itself is sugar-free as well. I've also found the handout for this investigation to be a little bit confusing for the students to try to navigate on their own. So chunking the handout with the students and helping them to set up parts 1 through 4 will end up saving you a lot of time in the long run. In this investigation, the indicators are the same as before, where iodine is testing for starch and the Benedict solution is testing for glucose. In tube A, you'll have just water, food, and iodine, no amylase. In tube B, you'll have amylase, food, and iodine. Both will return a positive result for the starch, which is expected, since the complex carbohydrate was present to start with. In tube C and D, you're testing for glucose, which should not be present in the solution that sat overnight. So tube C is testing just the food, the water, and the indicator, which is the Benedict solution. This one should not show a change, meaning no glucose is present still. However, tube D, which has the food, the amylase, and the Benedict solution, should have a positive reaction and change a different color from the blue. Now, this color that it could turn to could be anything from green to yellow to orange to almost a brown. This is the sample that is modeling that the enzyme in the saliva mixing with the food and breaking the starch down to create the glucose had not originally been there in the food, and confirms that a chemical reaction has happened. So through this unit, you will be adding a couple of words to our word wall. In this particular lesson, we encounter the words amylase, enzyme, and saliva. Your students may wish to add these to their earned words, or they may not, depending on their familiarity with it. The words that we reinforce or apply from previous units are chemical reactions as well as physical changes. There are a couple of posters that will be used. The word wall is the main one that you're going to revisit because you're hoping to have those chemical reactions on your word wall already. In addition, the students are going to create that handout that's going to collect their data. And there's no large posters or materials made that will carry over into future units. So that's it for this lesson. Thank you so much. I hope that you enjoyed doing this investigation with your students. And in the next lesson, we're going to dig in a little bit deeper on some more data.